Welcome to Smart Academy tutorial. So in today's class, it's just a continuation of dimensional analysis. Okay, so and please don't forget to subscribe to our YouTube channel and follow us on Facebook on our education website, Smart Academy. Yeah. So I will start with a question that I gave you as an assignment. We will solve it together so at least you revise on that one, and then I'll give you the dimensional equations that will be helping you to derive relationships as you'll be solving various questions on this topic. Okay, so we can start. So the question was find x, y, and z in the expression. I gave you the expression to say it's v to be equal to c. Okay, so c p less the exponent x, then we have a law, okay, to the power y, and we have v to the power z. So if I said v is speed, v is speed, and p is pressure, p is pressure, then rho is density. Okay, rho is density, v is volume, then c, okay, then c is a dimensionless constant. Okay, c is dimensionless constant. C is dimensionless constant. So find the values of x, y, and z. Find the values of x, y, and z. If the expression is that c p to the power x, rho to the power y, and v to the power z. If v is speed, p is pressure, v is volume, and c is a dimensionless constant. Okay, the question is very simple. Okay, very simple. Okay, so let's start. So when you have been given a question like this to find the values, so the key thing is understanding the unit of each component and reducing that unit to its simplest form involving length, mass, and time. Remember, dimensional analysis we deal with the fundamental basic fundamentals like length, mass, and time. I gave you the dimensions of this one: length, mass, and time. Okay, so we don't have enough space, so I'll be erasing. So you can have a script where you'll be writing the most important point. Okay, all right. So I said the important thing is to find out the unity of each component and reduce that unit to its simplest form. That will help you to solve this question. Okay, I hope you remember the question. We have erased. So remember the expression was v. Okay, we have v to be equal to c, then p less x, and law y, then v z. Okay, so now we want to find the values of this. Let's reduce this what have been given to its simplest form of unit. So v, we know the SI unit for v is meters per second, so we can write as meters over second like this. And pressure, we know that pressure is force over area, so meaning it's Newton over meter squared. Okay, but remember that 1 Newton is actually equal to 1 kilogram meter per second squared. That is 1 Newton. 1 Newton is equivalent to v. Okay, so if 1 Newton is that, then to find the unit for pressure, we're going to say 1 kilogram meters over second squared. Then you divide meters squared. When you divide this should give you the unit of pressure to be kilogram over meters by second squared, like this. So these are the units of pressure. Okay, the SI unit of pressure. Okay, then for the law, which is density, you know, density is mass over volume. So mass, we use kg over meter cube. Okay, that is density. So this symbol is law. You read it as law. Okay, and volume, we know volume is meter cube. And c in this expression, okay, c is a dimensionless constant. A constant has no unit. So c will not have any unit, just like the way you don't have a girlfriend. So this c can be ignored. like the way you've been left on brute by your class. So even this one can be left on brute. So let's proceed. With the same expression, now let's plug in the SI unit for each component. The SI unit for each component. So the SI unit for V, of one that is the meters per second. Okay. Then C can be ignored, like the way your class ignores you. Then we have kg, okay, over meters squared. Meters times second squared. All this raised the power x. Okay. Then we have for law, which is density, it's kg over meter cube. All this raised the power y. And for volume, it's meter cube raised the power z. What we are looking for actually is these, the values for x, y, and z. Okay. So let's proceed. Now, let's express the units as dimensions now. Let's express the units as dimensions. Okay. So the dimensions for length, okay, for length I said it's L in square bracket. If you remember in the previous class, the dimensions for mass, is M, capital M in square bracket, and for time it's capital T in square bracket. So these are the dimensions. Okay. Now let's plug in let's replace the SI unit with its dimension. So for meters per second, for meters it's L, capital L. So we use capital L, which is length in square bracket, over T in square bracket to be equal to mass. Okay. So mass, kg is mass. So it's capital M in square bracket. Okay. Capital M in square brackets over, so meters times second square. So meters, so you plug in L, capital L in square bracket, then you multiply T, the square should be outside T, okay, in square bracket. All this should be raised to the power x. Then you multiply by so we have kg over meter cube. So kg is mass, so capital M in square bracket over L in square bracket raised to the power 3. All this the power y. Then we're going to have capital L in square bracket cube raised to the power z. Okay. So if an item has a denominator and you bring it up, its power becomes a negative. That's the rule that you're supposed to remember here. So if an item was a denominator and you bring it up, its power becomes negative. So that's what we're going to do here on this step. Okay. So my space is limited, so I'll be lazy. Okay. Hope you'll be following along. Hope you'll be following along. Okay. So now let's proceed. So here we get, if we bring the denominator to the as a numerator, so the exponent changes to negative. So we're going to say L, okay, then T becomes we have a negative, a power of negative 1, being equal to M, okay, M to the power x. So here you distribute the x, here the exponent. So even M will have an x, even this one will have an x, even this one will have an x. Even here you distribute the power, okay, you distribute the powers. So when you distribute, all this will look like this. The expression will look like this. Okay, the expression will look like this. M to the power x. So multiplied by L to the power to have a negative x, because it was a denominator, now it's a numerator. Then we have T to the power negative 2x. Okay, all this you're multiplying by M to the power y. It was a numerator, no wonder it's positive. So L was negative, was a denominator, so to have a negative, so negative 3, then y. Then all this again you multiply by L, okay, in square bracket, raised to the power 3z. Then you distribute the power. So here we'll put the like terms together by adding their exponents. On this step, we'll put like terms together by adding their exponents. The way you put you correct coins when you're broke, the way you arrange them nicely. Okay. So here let's proceed. So here on the left hand side, so let's say this is our left hand side and this is our right hand side. So we'll put the like terms together by adding their exponents. So on the left hand side, we're having L, okay, in square bracket. Don't forget T, then negative 1 to be equal to. So here we have like terms. So we have M having a power of x, and we have M having a power of y. So these are the like terms. So we'll just say M in square bracket, then we'll add exponent. We'll say x plus y. Okay. Then all this multiplied by the square of L raised the power. So we have here L negative x. Okay, let me just be using the different character points. So we have L here negative x, another L here negative 3y. another L on the left here, positive 3z as the exponent. So these will add them. So we're going to have negative x minus 3y plus 3z. Okay, then all this will multiply by t. Okay, all this will multiply by t raised to the power this should be a square bracket raised to the power negative 2x, which is here. Okay, it is here. Okay, it's on the right hand side. So this is our right hand side. Okay, from here, the next thing is we don't have m on the left hand side. You have to notice here on the left hand side, you only have L and T, but we don't have M. But on the right hand side, we have M. So what are we going to do here? So we don't have. What are we going to do? So what we're going to do is we'll introduce it, but we'll give it a power of 0. So you know this rule which goes anything to the power 0 is actually 1. So meaning we just introduce it. It's a ghost. So because it's like there, but not really there. Okay? It's like you're acting in a friend zone, but you are not really there. Reaching out. You get? Yeah, something like that. So that's what we are going to do here. So we'll introduce it. So we're going to say L the power 1, okay, then T the power negative 1. Then we introduce M, we're going to say M the power 0, okay, M the power 0. Then this should be equal to M the power x plus y. Remember we have M on the right hand side, then we have L here, the power negative x minus 3y plus 3z, we have a z here, plus 3z. Then all this you multiply by then t in square bracket, this should be raised to the power negative 2x. So this is our expression that we are having now. The goal here, we are looking for the values of x, y, and z. X, y, and z. So what are you going to do from here? Here now, you equate the powers of each quantity on the left hand side and right hand side. Here on the left hand side and then the right hand side. You equate the powers of each quantity. So if you equate, meaning forget about the bases, just get the exponent now to solve the values. So that's what we're going to do here, right? Okay, let's proceed. So when we equate the powers, so we're going to say the powers of L, okay, the powers of L and the powers of L on the right hand side. So the power of L here on the left hand side is 1. So 1 should be equal to the power of L on the right hand side is actually negative x minus 3y plus 3z. Okay, and for M is 0 will be equal to x plus y, or you can flip it and write as x plus y will be equal to 0. And the last one, t here on the left hand side is negative 1 will be equal to negative 2x. So from here it will be easy for you to find now the values. From here it will be easy for you to find the values. Okay, it will be easy for you to find the values. All right, let's find out now the values. So we'll start with negative 2x will be equal to negative 1. So we find the values of x. So we're going to say over negative 2 over negative 2. So our value of x will be half. Okay, so let's find now the value of y. So you go to this expression, x plus y should be equal to 0, meaning our x we know. So we're going to say half plus y should be 0. Then our y should be negative half. Okay, our y is negative half. Now let's find the value of z. The value of z, we're going to get this expression here. We're going to say negative x minus 3y plus 3z should be 1. Okay, we know the value of negative x, so it's negative. Then the value of x is actually half minus 3. The value of y we know is negative half. Okay, plus 3z should be 1. Okay, so this is half. This is half. So this becomes negative half, and this becomes positive 3 over 2 plus 3z should be 1. Okay, when we solve this, okay, it becomes like that. It will be equal to 1. So what are we going to do here? So we know that this is negative 0.5 and this is as good as positive 1.5 plus 3z should be 1. So if we solve this, this is as good as this will give us 1 actually. This will give us 1 plus 3z should be equal to 1. So our 3z should be equal to 1 minus 1, which is equal to 3z should be equal to 0. When you divide, our z should be equal to 0. Okay, when you divide, our z value is 0. Okay, since you have found the values of x, y, and z, you have found now the values of x, y, and z. You have found the values of x, y, and z. So the values of x, the value of x is actually the value of x of 1 to be half. Okay, so the value of x is half, and the value of y is negative half, and the value of z is 0. So from here, we're going to plug into the original equation that I gave you in the question. The expression was v to be equal to the constant c, the one you ignored, then p to the power x, okay, then you have below, then the power y, then v to the power z. So we're going to plug in the values that we have found. So the value of x will plug in where the x is as the exponent. So we're going to say v will be equal to our c, p raised to the power half, our low raised to the power negative half, and our v value raised to the power 0. So this part can be ignored. Okay, the one which is raised to the power 0. So we remain with v being equal to a c p the power half over low the power half. Now, the reason why I've brought it down because of the negative. Anything if it's less than the negative, meaning when it comes down should be positive like that. So this is positive. Okay. So if you notice, all our powers are half. So we can factorize half. We can say p over low, then our half becomes outside. So if we write like this, um, this also can be written as good as this. So v is equal to our constant c, then the root of p over log, like this. Then you have done the expression. We've already found the values the question was looking for. And if the question continues to say find an expression when you find the values, so this is the expression. Okay. Yeah. So another thing that I want to share in this video, I want to give you the dimension equations. At least it will be helping you to solve several questions on this topic. Okay. Right. All right. So dimensional equations. Okay. Dimensional equation. Dimensional equation. So dimensional equations. So let's start with the dimensions of area. So area is actually, area is length, length times length. Okay, it's length times length.